Welcome friends to another class. In the previous class we have dealt with the topic that is the soil erosion and types of soil erosion. Now we are dealing with the new topic that is mechanical soil conservation techniques. That is, we have degraded the land and the soil erosion reasons we have known in the previous video. Now I am going to tell what are the mechanical soil conservation techniques we can adopt. Soil conservation means that is soil is the top soil, that is 10 to 15 centimeter of the soil. Conservation means we have to conserve it, means we have to maintain that and in a healthy condition, that we call as a soil conservation. In that we include the first thing, that is contour plowing. That is, we have the plowing. We will do the deep plowing and plowing operations as a tillage operations while we take up a crop, or before a sowing of crop, to loosen the soil we are going to do this thing. In that contour plowing, contour word meaning is the elevation of a points which have a equal slope. That is, equal slope points are called as a contour. On that lines along that ridges, if you make the tillage, means if these are some of the points in that which are having equal slope, you are making the tillage in these form, then there will be equal elevation which is present among these all the plots, so that the water will come and will be stopped at this point. So it is called as a contour plowing. Definition is plowing along the contours of the slope to create a perpendicular slope, so slowing down the water runoff. That is, perpendicular slope is a very important thing in that. That is, while we are making a contour plow, example, this is the land and it is having a slope this side, then we have to do the plowing across these line, so that the water which will flow from above side will go and will stop at this angle. This is called as a contour flowing. That is, it reduces the speed of the water flow, minimizing the erosion and improving the water absorption. Next we have the topic terracing. That is, you can see from this image, these are like a terraces, like a steps. That is called as the construction of the steep like horizontal terraces sloping land. When the slope of the land is greater than 20%, we are going to take the terracing. That is, we have different types of terraces, that is bench terraces, graded terraces. While this contour plowing is done only when the slope of the land is very less, that is 1 to 5% below. In this range, if we are having a slope, then we can go for a contour plowing. And the terracing is done where there is a slope more than 10% up to 20%. In this range, if you are having a slope, then we are going for a terracing. In that we have the purpose to reduce the water flow. That is, the water flow from this region we will reduce, so that the water will come and flow in this direction, so that the velocity of the water cuts down. It prevents the soil erosion and allows the farmers to get the, that is, if there is a steep slope, example, in this way we cannot cultivate the crops here. So when we cut down it as a terrace, and that time we can cultivate the crops here. And these terraces will be made in such a way that, so that it will be having a slope this side like this, so that the soil whatever will come will deposit in this location. The types includes bench terraces, graded terraces. Large steps continue to steep hills. Graded terraces means gentle sloping. That is, this includes large steps, and the graded terraces includes the gentle sloping, means that it allows the water movement, that water can flow out of this. Then we can take the image of the check dams. This is an image of the check dam. In that, these check dams are constructed in the gullies. That is, as you can see, we have thought the gully erosion. There, the gully is formed due to flowing of water. On this location, we will construct these check dams. like this, and we will do a stone pitching here, so that the water will come and stop along with the soil, which conserves the soil, and the water will get infiltrated into this stone pitched wall, so that it increases the groundwater level. The definition includes small temporary dam built across the streams or gully to reduce the flow of water. As you can see in this image, the water speed has been reduced, so that the water will come and accumulate in this zone. Then the purpose is it reduces the gully erosion, increases the groundwater recharge by slowing the water runoff. Then we go to the contour bunding, same as a contour plowing. Here I have put the image of a contour bunds, that is we are making a bunds. Bunds means increasing the soil level, so that it will be along the contours of equal elevation, so that if there is a flow of water, the soil will come and accumulate at these zones at a equal elevation. This should be done in a perpendicular direction, so that the water will capture, allow it to the percolate into the soil and reduce the erosion. Then we have a concept called strip cropping. Strip cropping, this is a strip cropping means alternating of a strip crops, fallow crops planted along the contour slopes. This simple definition includes as we are having two types of crops. One is erosion permitting crops, and another one is erosion reducing crops. Here, some crops such as paddy, these are eroding. That green color indicate paddy, and some are legumes which will hold the soil. So these are erosion reducing, these are permitting crops. We will have the rows of these crops in a different strip, so that the soil will be conserved along with the water, since they hold the soil in the root zone of these plants. Then we have a windbreaks. The definition includes rows of trees or shrubs planted along the edges of field. You can see from this image, this is the row and edge of the trees. That is, trees will be planted along the edge of the crops, so that when the wind blows, these leaves will protect that small crops, these trees leaves, so that it reduces the speed of wind and prevents the wind erosion, particularly in the arid regions. Then we have a grassed waterway. Grassed waterway, this is that we have learned that the gullies will be water will at that position, water will flow at a high velocity. To reduce the velocity of the water, the grasses will be grown. As you see in this image, the grasses will be grown inside the way, so that it will be made a permanent way, so that the water flows, but the soil will deposit due to presence of grasses, that we call as a channels lined with grass to carry the excess water, that safely direct the surface water away from the field, so that water logging will decrease, so that the soil and water conservation occur. Then we have other methods. First one was a soil measures. Now the second one is a due to agronomic practices. The first one was engineering practices. The second one is agronomic measures, that to in situ conservation measures. That is inside the field. In situ means inside the field we are going to conserve the moisture. These are some of the methods include. The first one is infiltration and runoff. First we have to know the difference between the infiltration, runoff, percolation and seepage. When the water, this I assume this as a soil surface, and here we have a crop. These are a root of a crop. Okay. When the water enters the soil, this thing we call, that is inside the soil going, this is infiltration. That is entering of the soil profile is infiltration. Then we have a, here up to here we have a root zone. When the water will go beyond the root zone, we will call it as a deep percolation. deep percolation loss. Okay, then if the sideways movement of this water occurs inside soil profile, then we call it as a seepage loss. Okay, then if the soil surface has completely compact, so the otherwise the soil is uniformly wet, at that time the water will flow on the ground, which is called as a runoff. As from the definition, the process by which the water enters the soil from surface is called infiltration. Infiltration rate improves the soil moisture, enhancing the plant growth. Here we have two types of soil with the texture. The first one is clay soils, another one is sandy soils, and another one is loamy soils. When we have clay, there will be clay percentage more, sand means sand percentage more, loamy means medium soil. In the clay soil, we will be having more number of micropores. So the infiltration will be more, but the rate of infiltration decreases because it is having a compact pores. When the sandy soil is there, we will be having more number of pores which are bigger, so that the infiltration rate increases. So always in sandy soil, infiltration rate is more when we compared with the other clay soils. Okay, so sandy soils has a more infiltration rate. Then when we come to the runoff, the movement of water over the soil surface when it is cannot be absorbed, that is when the soil is full of moisture or it is compact, that will follow the excessive water to move, which we call as a runoff. That is that thing. Then some of the in situ moisture conservation techniques are mulching of the crop. We have learned two types of mulching we have seen in our crops. That is, in some of the crops we will be having black paper mulch, that is in tomato crop. We will be having some of the mulch in horticulture crops. So this mulching is done, that is practice of covering the soil surface with organic or synthetic. When we come to the plastic mulch, it includes polythene sheets. We have two types of polythene. One is black polythene, another one is white polythene. What is the use of this white is, here it will reflect the sunlight, so that it needs less water, but black will absorb the sunlight, so that the soil increases, weed seed dies along with the pathogens dies. Organic mulch includes straw, leaves, and crop residues. These are the crop residues after our crop which we get. We can use that as a mulching sheet. The benefits is reducing soil temperatures because it will be preventing the sun rays entering into the soil. Then it will conserve the soil moisture because it is present over the soil, reduces the evaporation, then prevents weed growth since the weeds dies inside the soil, inside the mulching sheet. Then we have contour forming. As in the above, I have said the definition that we have contour plowing and contour bends. Contour forming is plowing in a contour lines. That is, we are cultivating the crop along the elevation of equal slope, which we call as a contour bends. Plowing along the natural contours, that land reduce the water and increase infiltration. The aim is to increase infiltration and reduce the water runoff. It minimizes soil erosion, helps the water to percolate into the soil. Then we have a strip cropping. As I told, we have two types of crops, that is erosion permitting and erosion resisting. Erosion permitting and erosion resisting. The erosion resisting crops include our pulses because they will hold the soil tightly. Example, some of the pulse crops we can take as a example, such as horse gram, then cowpea. These crops will hold the soil. Then we have erosion permitting crops. They are rice. Those crops will permit the erosion. By growing the alternate strip of erosion prone and erosion binding crop like grasses and legumes. Legumes means pulses. We can go for a strip cropping. It reduces water runoff, enhances infiltration, protect the soil from erosion. Then we have a cover cropping. That is, the definition is growing of crops like legume grasses during the off season to protect the soil and improve its structure. we have this cover crop. Best example is our cowpea crop, that is which will have the more leaf foliage, so it will cover the soil surface. We have some of the other cover crops such as we can use the vetiver grass or other some of the grass species to cover the land surface, which will grow very fastly when we compared with the other crop. The best example we can give is a cowpea, which reduces the soil erosion, enhances soil organic matter content, improves the soil moisture retention. Then we have the conservation tillage, that is we will reduce the tillage. We have two types of tillage, that is primary tillage, secondary tillage. In that we will do lots of tillage operations such as deep plowing, then we will take the disc harrowing, some of the measures. But it is minimal soil disturbance method like zero tillage. That means we won't plow exact all the land we have, we will just take the opening of the furrows inside the land. In that we will sow the seeds so that the soil gets less disturbed and it maintains the structure and moisture of the soil. It enhances soil structure, reduces runoff, retains soil moisture. Then we have the crop rotation. The best practice which the farmer can adapt is crop rotation. That is, in the first alternatively rotating the crop. That is, in first year he can go for a crop like as maize. Then in the second year, which is a cereal crop. In the second year or a second season, at least. The second season means if he take this crop in Kharif, in Rabi season, you should go for a pulse crop, that is a legume crop, so that this has the ability to fix N. That is example for the pulse crops include our horse gram, cowpea, red gram. These are some of the pulse crops which we can go for in the second year, so that these will fix the soil nitrogen and enhances the soil fertility and improve the soil structure. If you do monocropping, then same crop, maize is an exhaustive crop, it will be grown so that it will reduce the soil fertility. There is no n fixation, so we have to go for crop rotation. Then we have the ridges and furrow system of planting. In that we have a ridge and we have a furrow, then we have a ridge, then we have a furrow. Here we will plant in the middle of the ridges, that is here we will plant the maize seeds. What is the use of this? This is sloping the land to reduce the runoff. Since the water will flow like this, means the water will come and it will store here, so that it won't take the soil much, so that in these furrows the water can also flow and the crop can also grow. So the benefits include encourages the water percolation, reduces erosion and slopes. Then we have a broad bed and furrow. We will have a 90 to 1 meters, that is 100 centimeter beds, followed by 30 centimeter furrows for water flowing. We will make this as a big bunds. Then we will cultivate the crops on these shallow furrows, okay, here in this location. So we will have the water to flow here. The water will come and stop at this stage because there will be a bund present. Then it will flow slowly around this and the crop gets the water. It increases the infiltration, helps to manage the excess runoff, that is excess water in the high rainfall area. Next we have the tillage concepts in rain-fed farming, that is flowing and fallowing. That is, the minimum tillage is the best tillage operation which we can take in the tillage in rain-fed farming. That is purely based on the natural rainfall we will grow the crops, that is rain-fed farming. Tillage means that is the disturbance of the top layer of the soil using the implements. In that, tillage refers to the mechanical manipulation of the soil, prepare it for planting of the crop, because some of the plants require fine tilth condition. Example, sesame. These seeds will be very small. It requires a small quantity of the soil fine tilth particles for its germination. In rain-fed farming, where the water is limited, the tillage practices are aimed at conserving the soil moisture and improving the soil structure. we have to conserve the soil moisture. If you are making a minimal tillage, then the soil moisture will be conserved along with the less disturbance to the soil structure, so that it will also improve the soil structure. The main goal is that is reduce soil compaction, improve water infiltration, minimize soil erosion. If you go on tillaging the soil, the soil will become very loose. So when the flowing wind and blowing wind, flowing water will come, that will erode the soil particles. Then plowing, that is after, that is in the tillage only we have plowing. That is, plowing is the process of turning over the upper layer of the soil to the bring the fresh nutrients. We have the top 15 centimeter of the soil, below that we have some soil that we will turn up, because it will contain some nutrients. Then we have types of plowing. That is, in that we have primary plowing, secondary plowing. In primary plowing, the first operation is when we cultivate a crop, we will go for deep turning of the soil to break the compact layer, that is in the topmost layer of the soil. We will turn using some of the implements such as disc plow or country plow, iron plows. Using tractor, we will break down the compact layer and incorporate the organic matter. It includes deep plowing, shallow plowing. Deep plowing means up to the 15 to 20 centimeter depth we will plow, and above, that is 0 to 10 centimeter, includes the shallow plowing. Used for light soils, that is where the water depth is very less. At that situation, we will do the shallow plowing. Then we have a secondary plowing, that includes more refined operation aimed at creating fine seed bed. That is, after primary tillage, we will take up the some of the secondary plowing. That is, we will use the planking to level the land, break the clods using some rotavators as instruments. We can do the fine tilt. Then importance in rain-fed farming. As I told in the previous class, what is the importance of rain-fed farming? That is, it will contribute 60% of the people are dependent on rain-fed farming. 40% food grains will come from rain-fed farming. Soil moisture conservation is important since the plowing helps in breaking the clods, crust of the soil, improving water, but the minimum tillage is very important in plowing. Then we have a weed control. When we plow the topsoil, there the weed seeds will get inside the soil and they will die due to the turning. Then we have soil aeration. Due to the soil turning, we will have a more soil erosion. Then what are the challenges in this? We have a soil erosion, that is excessive plowing, that I have told that minimum tillage is desirable. If you do more plowing, the particles of soil will lose and it will become evaporated. That is, erosion will be more due to water and wind. Soil moisture loss, that is overplowing, can also result in the loss of soil. That is, we have a soil layer. Here the moisture will be so stored in a different layer of the soil. That is, example, in the below soil we will be having a more moisture. This above soil, here we will be having a moisture. When we will do the plowing operation more times, the thing is, this layer which is having the moisture will come up, so that it will get eroded, it will get evaporated, so moisture loss occurs. Then following is a practice of leaving the land uncultivated for a season to conserve the moisture and restore the soil fertility. That is, we are not going to cultivate the land in a season or a year. That definition we call as a following. In that we have two types. The first one is bare fallowing and second one is green fallowing. Bare fallowing is leaving the land completely uncultivated with no crops. That is, it reduces the soil moisture loss through evaporation and natural regeneration of nutrients. The natural regeneration of nutrients occurs due to microbial activity and some of the weeds grown on that land. If you leave the land bare, there the weed may grow and the soil will get the nutrients turned inside the soil when we plow along with the weeds. Green fallow means we will use the leguminous cover crops during the fallow to enhance the soil fertility. It improves the soil organic matter, fixes nitrogen, and soil erosion will be reduced. Then the importance in rainfed farming, that is what is the importance we have to give in rainfed farming is moisture conservation, soil fertility, weed control. These are the important things, that is moisture will be conserved because we have less rain, there is no source of irrigation in rainfed farming, so we have to conserve what are the moisture which is already present. Then we have to maintain the soil fertility because the soil will be having the less water, so there will be less nutrient decomposition and less microbe activity, so less fertility. Then weed control, because the soil is having a fallowing, it will reduce the weed population by preventing the weed seed and germination. Then some of the challenges include land degradation, loss of income. Land degradation is prolonged bare, that is if you leave the soil uncultivated you won't get the income, so it will become as a land degradation. Then we have a loss of income, that is following means you will not cultivate the land, at that time you won't get any returns from that land, so it will lead to the loss of income. Then we have the topic, that is plant EDO types. This is a topic, EDO type or a model. This is a idiotype, means this term idiotype was coined by the scientist Donald. The definition includes the plant idiotypes refers to the ideal plant types that are genetically designed to perform optimally under a specific environmental conditions. That is, these are the plants which are performing better when we give a particular situation. Example, excess moisture or deficit moisture. In this condition, we will create some of the characters among the plants. Those will perform very better and give uh, some amount of yield, which we will call as a plant idiotypes. Objective is to, in the, that is I have told, water scarcity, high temperature and low fertility, these are the challenges, so we need to develop the plant types for these conditions. Then the objectives include, the aim is to develop the plants to shallow traits like deep root system, drought tolerance, efficient use, early maturity. The thing is, deep root system. The deep root system comes when, this is the thing, we have a crop. Deep rooted crops comes when there will be a deep root system of the crop. It can extract the moisture from the lower area. In a drought areas, air from the soil it will can take, so deep root system are preferred. Then drought tolerance. Some plants such as sorghum will have the rolling leaf ability. The leaf will get rolled so that sunlight will leads to less water evapotranspiration from that plant. Efficient water use, that is finger millet crop, by taking less water it will grow nicely. Then early maturity, since early maturity means if the crop is having less duration to complete its life cycle, it can thrive well around in the drought condition. The characteristic of dryland plant etiotypes include drought resistance, that is it should have the ability to survive in the shortage of water. Then efficient use, at least it should reduce its transpiration to to prevent the loss, and it should be alive in a such situation. Then deep root system, so that it can take the root water from the reservoirs. Then early maturity, if the duration of the crop is only 30 days, then it require only the water of 30 days, so that it will mature early and it will leads to the resistance against the drought. Then we have a low nutrient requirement. If the crop is having less water, we have a saying that the rain-fed areas or dry lands will be hungry and thirsty too. That is, hungry means they are devoid of nutrients and thirsty means they are less of water. If there is water only, the root can uptake the nutrients, so the nutrients requirement of the crop should be very less in such condition. Then we have a crops for the dry land, that is in the dry lands we can cultivate some of the crops. They are included as millets, that is these are drought tolerant crops. That is, we have different types of millets, that is bajra, finger millet, foxtail millet, little millet, proso millet, kodo millets. We have many number of millets that we can include. The characteristics are same, that is drought tolerance, short duration, nutrient rich, that is iron rich, calcium rich in fiber rich in the foxtail millets. so we can grow them. Then pigeon pea, red gram, and chickpea, that is mung bean, these are having a ability to nitrogen fixation, that is these are the pulse, since these have a rhizobium bacteria in the root zone, they can fix the nitrogen. And these have a water use less more water use efficiency because they need less water, so they make it suitable for the dryland condition. Then we have oil seeds, that is groundnuts, sunflower, and sesame. They have the very deep root system, so that they can extract the water, that is safflower has a deep root, so it can take the water from the deeper layer of the soil, so it can thrive in the moisture less condition. Then we have a drought tolerance resilience, that is these crops can withstand the long dry spell. Dry spell means without the water for a 10 days it can survive at least by living.